All right, gentlemen, welcome. Hope everyone is doing well. Let me see. Let me make sure my audio is working properly. I can just close that out for now. Let me see. Testing, testing. That looks healthy. Testing, testing. That looks good. Okay. So no major announcements. Let me see. So this is the end of week 6, right? So we have week 7. Week 8 is when I want to do exam 2. It should just cover sections 1, 4. Let me see. Who's this? This student. It should cover sections 1, 4, 1, 5, and 1, 6. And yeah, I'm trying not to move into chapter 2. I'm trying to save that for after exam 2. For exam 2, you can anticipate it being pretty much the same as exam 1 with the online component, but I do want to incorporate an oral component where I'll basically make a scheduling wizard where people will sign up for whatever slot is convenient for them, and then you got to defend. You got to defend against like some questions for 10 or 15 to 20 minutes, somewhere between 10 to 20 minutes. And not anything difficult. It should be stuff that you should know. I just trying to get a feel for where you guys are, because our interaction and our engagement is so like removed. But we'll see that. We'll explore that more as we get closer to that time period. So there we go. That's the sound I needed to hear. No, are you okay? So we're going to. So what I've been doing, I'm going back through like the questions, but I'm trying to see, can we find, because I assign certain homework questions, and when I make your exam, what I do is I pull from all the questions available, right? So there's a good chance that there are going to be questions on the exam that's not necessarily assigned in the homework. It's the same content and it's the same, you should be able to handle it, but you just may not have seen it before. So I'm trying to see, okay, can we go through and can we find potentially some questions that might not be in the homework that could potentially pop up on the exam, right? Because again, it's all about the concepts. It's not about it being verbatim. It's about, okay, is it the same concept? What concepts do we apply? Can we figure it out? So that's what we're going to take some time to see. I'm going to go ahead and suppress my audio so I can focus. We're going to see, can we find some of those questions that could pop up on the exam that's not necessarily in the homework. Let me get this student. They were here. They were here in the previous. I hope they come back up. I told them that they needed to come back. They came at the wrong time. Yeah. Okay, that might be them. Let me see. I think I got that student, and I think they got knocked off. And no. Okay, either way. Let these guys in. I see the chat. I am coming over there. Let's see. No, stop. Lab attendance. I haven't done anything with like a lab grade. Like I'm not sure how are you saying 0 for lab attendance? Are you talking about like the lab, or are you talking about our class times? Like I'm not really sure. But I haven't checked what Dr. Lamar has been sending me. Um, if you haven't gotten credit, yeah, just contact her. Because as long as I guess I have to kind of go through the files. I haven't checked yet, so I haven't given anybody. I haven't done anything with like lab attendance credit. But as long as Dr. Lamar has a record of you like submitting your work, I haven't checked it yet. So I don't. That's probably why you might be seeing that grade. But I haven't done anything with like lab grades yet. What are you guys' questions about the attendance with lab? The main thing. So the main thing with lab is whatever it is that Dr. Lamar says you need to be doing. And so what happens is like she has a log of the work that you do, and then she sends me a report. And then at some point, I'm going to sit down and go through the report and just see, do I have a record of you guys working with her? And then as long as I see your name in the report, you get credit. That's how that goes. But I haven't done it yet, so that might be why you're seeing a 0. But if you know you've been doing the lab and you're doing the things that she asked you to do, that's more than one. So there's a question that says today I got an 80 for attendance. So so the first thing is the attendance that you see on Blackboard with the attendance, that grade, that doesn't have anything to do with your grade. That's just a record. That's just for record keeping, right? So that grade that you see for attendance on Blackboard with it, that's not your actual grade. That has nothing to do with your grade. All right, that's just saying, okay, out of all the sessions that we've attended, you've attended 80% of them. But that has nothing to do with your grade. It only becomes an issue if you have like three or more. At 3, I kind of like it just catches my attention. But at 4 unexcused absences, then I'm like, okay, wait, like I need to track this person down and see what's going on. All right. And that's the only time it's an issue. But that grade that you see for attendance is not factored into your grade. The grade that I'm going to do, like for the lecture grade, that just pretty much just comes from Pearson. Whatever I see on Pearson, I'm going to go through. Basically, if that's something with the lab, as far as the time slot, that's Dr. Lamar, right? You have to contact her. Because that's separate from me. So that's her thing. Let's go like this. I still got students coming in. I got this student, and then let me check the chat real quick. But yeah, the attendance, the main, as far as I'm concerned, like, oh, that's not what I was trying to do. For our component, as long as you're like coming on a regular basis and as long as the main thing is that you're getting your assignment submitted on Pearson and you're just showing up, then I'm not going to let something like attendance get in your way, right? Greetings. Yeah. So with the signing up for the lab with Dr. Lamar, just email her. She's much better about replying to emails than I am. I'd be like in my own world, and I just miss them very easily. Yeah, let me make this disclaimer as well. If you did send me an email, and if I haven't responded, now is the time you want to kind of address those concerns. Because when I leave you guys, I go off and I try to generate income so that I can live, right? So I'm always kind of busy. But so this time was really intended. My intent was for this to be like a Q&A to get anything, questions about homework or anything. This is the time. This is the best time for me right now. Okay, so what we're doing, we're going through questions and we're trying to see, okay, I'm trying to see, can I find questions that I may not have assigned in the homework that could potentially show up on the exam, right? And it's just kind of a review. And I'm just trying not to move forward into chapter 2 just yet. I'm trying to save chapter 2 for after exam 2, so that way, I'm just trying to keep the ideas and concepts compartmentalized. Again, and we don't have to work on these questions specifically. If you want me to go to any other question, we can even go back to questions from exam 1 because it's all connected. We can go to something else. We don't have to do these. I'm just doing this to kind of fill the air. So this one, this question comes from section 1.4. It's question 37 from the back of that section. It says, using the graph of the function, find the following. It says the intercepts, if any. Okay, so x-intercepts. I think this one we can just look at the graph, right? So the x-intercepts, where it crosses the x-axis. So this is 1 and -2. So -2 and 1. -2, 1. Okay. Y-intercepts crosses the y-axis at 1. If this is 2, then this is 1. Okay, I'll check that in just a moment. Okay. The domain. So in a graphical sense, the domain is the very left to the very right, right? So the far left x value is here, which is -3. The far right is +3. Another way to visualize domain, if we take this image and smush it onto the x-axis, domain is going to be all those x values that the smushed image touches, right? So if we smush this vertically onto the x-axis, Give me just a moment. This is this guy, okay? If we were to smush this onto the x-axis, it would touch the x-axis going from -3 to +3, right? So the domain here goes from -3 to 3. And then the other part is we need the proper grouping symbols, right? So to kind of recap, parentheses means we get really, really, really close to that number, but we don't include that number, versus brackets means we get really, really close to that number and we do include that number, right? So I think this graph actually does touch the -3 and the 3, so that means we're going to use, hopefully you're thinking brackets. Let's see, okay? And then the range. So if the domain is the very left to the very right, I'm going to check the chat in just a moment. If the domain is the very left to the very right, the range is the very bottom to the very top, right? So the lowest y value here is 0. The highest y value here is 2. Again, if we were to take this image and smush it onto the y-axis, it touches the y-axis from 0 to 2 and all the points in between. That's called a projection, that smushing concept. So the range goes from 0 to 2. I think it touches both of these points, so they get a square bracket. Okay. Okay, increasing. So increasing in a graphical sense, when we trace the graph left to right, it should be going up, right? So initially the graph is decreasing, so we're going to ignore that for right now. But it is increasing as x goes from -2 to 0, and then it's also increasing as x goes from 1 to 3. So -2 to 0 and 1 to 3. We said it's increasing as x moves from -2 to 0, and then 1 to 3. And increasing, decreasing, and constant for our context, I think we should always use parentheses. What the parentheses does, because you don't reach those endpoints, you're always guaranteed to have at least 2 points to compare, right? If we use a square bracket and we're on the end point, then we're not always going to have a second point to compare. So for our discussion, I'm under the impression we should always be using parentheses when we're doing increasing, decreasing, or constant. Okay, versus a square bracket. Let's submit this. Okay. So then if that's increasing, then we can also talk about decreasing. So I'm just going to use the image there. So again, we said this should be in parentheses. It's decreasing as x goes from -3 to -2, and then a second interval as x goes from 0 to 1. 0 to 1. Okay. Okay, and then even, odd, or neither. Oh, constant is never flat, so the graph is not constant on any interval. Constant would be a flat graph, flat horizontal. Let me see. Even is the same as y-axis symmetry. Odd is the same as origin symmetry, and then neither is neither of those. I don't think we have any kind of symmetry, because if we fold this on the y-axis, they don't match up. These aren't symmetric about the origin, so this is an example of neither. Okay, let me check the chat. I'm gonna go ahead to the next question, but let me check the chat. Ooh. All right, let's see what's going on there. Yeah, you got the attendance. So if you're once you make it into my Zoom, you've gotten your attendance. Let me see. All being full in the past, gone every Thursday. Yeah, you definitely, if you sign up for a time slot and it's full, honestly, I would just contact Dr. Lamar, because she runs the lab, so she would know the proper thing. But you definitely want to just be in attendance, and but talk to her. She's the one that knows the details and the nuances of the lab portion, because she's running that one, right? Okay, these are good questions though. I'm hoping you guys are able to find your way. I know this is a little weird, but I still want you to do what you need to do and keep moving. I don't want anybody left behind or anything like that. Let me see. So let's look at this one. Let me see. Okay. It says the graph of a function is given to the right. Use the graph to find each of the following. Now it looks like we have some asymptotes going on. It looks like we have a vertical asymptote and a horizontal asymptote. Okay. All right. Let's hit OK. So the domain. So let's look at this graph. So the asymptote, what these dashed lines mean is that we'll get really, really close to them. You can cross a horizontal asymptote, but the vertical ones you generally you don't touch it, right? You get really close to these lines, but you generally don't touch them. Okay, so the domain. So the domain is going to be the very left to the very right. So the far left, you have to understand that we keep zooming out to the far left, and it just keeps going. So the far left in this case will be negative infinity. But the far right, we don't have anything showing up like past this asymptote, right? So this asymptote occurs when this vertical asymptote occurs when x is -2, right? So the far left is negative infinity, and it gets really, really, really close to x equals -2. But again, vertical asymptotes, we don't touch them. It gets close, but we don't reach them. So the domain in this case, the far left is negative infinity. The far right is -2. Because it's a vertical asymptote, we get close, but we don't touch. So that's why we use a parentheses over a bracket. And infinity, we always use a parentheses. Okay? So it should be this. Check the chat. Let's keep it moving. The range. So the domain is the very left to the very right. All right. So then the range is the very bottom to the very top. So if we go back to the image, so with this horizontal asymptote, it basically gets really, really close to this y value of y equals 0, but it's not gonna touch it. Sometimes it does cross the horizontal asymptotes, but usually that's brought up. So the very bottom, it gets close to y equals 0, and then the very top, it goes off to positive infinity, right? So it doesn't actually reach the 0, so it goes from 0 to infinity. Infinity always gets a parentheses, and because there's an asymptote, we're going to put parentheses, meaning we get close to 0, but we don't actually touch it. We don't actually reach it. Let me see, 0 to infinity, maybe, oh, sorry, okay, I see now. So this horizontal asymptote is not on 0, it's a little bit hard to see, but it's actually, the horizontal asymptote is y equals 2, right? Y equals 2. So we just need to change it from 0 to 2. So the very bottom is 2. We get close to it, but we don't reach it, and then it goes off to positive infinity. Okay. Let's see the chat. X-intercepts. Okay, let's look at this. So x-intercept is where it crosses the x-axis. It never crosses, right? So no x-intercepts. Looks like there are no x-intercepts, and there are no y-intercepts as well. Okay. I think we got more, so let's keep going. Increasing, decreasing, or constant, right? So as we trace the graph left to right, starting from the far left, as we trace it left to right, notice the graph is going up, 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 is always increasing. It looks like it almost flattens out, but with asymptotes, there's always going to be like a slight incline. All right, so it doesn't actually flatten out. It gets really close to being flat, but it doesn't. The slope gets almost 0, but it doesn't actually get to 0. So that's just the concept of asymptotes, right? And so, if you weren't engaging like a mathematician to explain that, you wouldn't really know something like that on your own, right? So that's the point of these interactions, to kind of explain those concepts. It should be increasing. It's never decreasing, and it's increasing over the entire domain. The domain, we said, went from negative infinity up until, what's the x value? Was that -2? I think it was -2. I think that was it. So it should be increasing over the entire domain. Okay. Let me check so now I'm not even really sure. I had a student that's scheduled for this time. They showed up in the previous class, and I said, hey, I think you're in my next class. You need to come back. And they didn't come back. So I'm like, should I give them attendance credit or no? What say you, present students? If you say to give them attendance credit, I might give them attendance credit. I'm still not going to let that be the deciding factor, but I'll take your input into consideration. But I definitely, because I told them, I was like, because when they showed up in the previous class, I was like, I think you're in the next one. I'm about to end this session, and I took a 10-minute break. I said you need to come back, and I don't know. Okay, so if it's mute, if it's mom, they're probably going to be marked as absent. I need to make a note. I think I can make a note though. Let me see if I can make a note. I think I can make a note. It was this student. I just need to figure out how to do a note. I'll worry about that later. Okay. Okay. Let me see. That's fine. Because my hesitation to giving that student credit is because I don't want them to make it a habit of coming to the wrong class. All right. I don't want to encourage that. And I specifically said, hey, I need you to come back to your time slot. Constant, I don't think this is constant anywhere, so there's no solution. Okay. Okay, so odd means origin symmetry, so there's no symmetry about the origin. Even means y-axis symmetry, so there's no y-axis symmetry, so I'm going to say neither. Okay. All right, let's do this one really quickly. Domain. Let me see. Do we have... So this looks like a log function. So we should have there should be a vertical asymptote. I know you can't really see it, but we have a vertical asymptote on the y-axis, right? What is the domain? So the very left is going to be negative infinity up until 0, right? So we're going to say this goes from negative infinity up until 0. Infinity always gets parentheses, and 0, again, I know it's not showing the asymptote, but that behavior is like a log function. So that means it gets really close to 0, but it doesn't actually reach it, so I'm going to do parentheses there. That means we get close to x equals 0, but we don't reach it. The range is the very bottom to the very top, so the range of log functions, the very bottom is negative infinity, and the very top is positive infinity. So this one should be all reals. Let's see. Yeah. Okay. X-intercept. I think it gave it to us, right? X-intercept is, let me see something. Type in integer, so they just want -1. And the y-axis, I think there's no y-intercept. This one, so I should be doing B. I just put -1. Okay. Yeah, I think next time I'm just not going to let that student in. Yeah. Like if they showed up, then it wouldn't be an issue. But I don't want to encourage. I don't want to encourage to be showing up to the wrong class and not get their credit. All right. I'll let it go for today. But if I notice it again, I'm not going to do the same thing. Okay, let's keep moving. What's the time? Okay. Intervals of increasing. So this is an increasing. Let me see. As we trace it left to right, the function goes down. So this is monotone decreasing, which means it's always decreasing. It's never increasing. It's never increasing. It's decreasing over the entire domain. Never increasing. It's decreasing. So the far left is negative infinity up until x equals 0 with the parentheses. Okay. Constant. It never flattens out, so there's no solution. Okay. And there's no symmetry, right? So odd means origin symmetry. Even means y-axis symmetry. So neither of those occur, so we're going to say neither. All right, so this is called a piecewise function. Basically, it's just multiple graphs on one plane, right? And so these restrictions tell you which part to focus on. So for instance, for part A, it says find f of 1. So when x is 1, if x is 1, notice that 1 is less than 3, so that means we use line 2. So if we're using line 2, no matter what x we choose, the output is always 3 in that case. Okay. If x is 3, then that means we use line 1 because it says use this line if x is greater than or equal to 3, right? So x is equal to 3, so then the output is going to be x itself, which is in this case 3. Okay. If x is 5, notice 5 is greater than or equal to 3, so we use the first line, so then the output is x, so x in this case is 5. Okay. When we're less than 3, it's going to be a horizontal line of y equals 3. So it has to be either b or d. And then when x is greater than or equal to 3, it's a diagonal line, right? And it's closed in because that's just what happens here. Because it's defined when x is 3, it just happens to be 3. So it should be d. All right, another piecewise. Okay, so when x is negative 19, if x is negative 19, this says to use line 2. So then the output is going to be negative 3. No matter what x we choose, the output there is going to be 3. If x is 13, then we use the first line, which is positive 3. Notice that this is not defined if x were equal to 0 because neither one of these say equal to 0, so they should both be open circles. Going off to the left should be negative 3. Going off to the right should be positive 3. It looks like A. Looks like A is the only one that behaves properly. Okay, let's go with A. The domain. So if A is the correct graph, the far left, notice if domain is the very left to the very right, another way to visualize domain, if we take this image and smush it onto the x-axis, that's another way. So if we took this image and smushed it onto the x-axis, notice that every x is accounted for except x equals 0, right? It's never filled in at x equals 0. So we wanna write an interval that captures all real numbers except 0. So then the far left is going to be negative infinity up until 0, parentheses. I'm using this thing called union, and then we want to go from 0 to infinity. Hopefully that makes sense. You have to like speak up if it doesn't. Otherwise, I just kind of keep going. You have to like stop me and get my attention. That's part of the reason why I want to do the oral exam because it's so quiet, you know, and I feel like I'm talking to myself, but I just ignore it and just kind of keep moving. But it's kind of a challenge, you know. Like if we were in class, I would look you in your eyes and ask you questions, and like I can usually tell. Anyway, what's the range? The range is the very bottom to the very top, right? So the very bottom, now because this is a horizontal line, if we took this image and flattened it onto the y-axis, these two would collapse to just points, right? So the range is just going to be the value, what, negative 3 and 3. It's only two output values. That's why they use curly brackets, right? So we're not talking about an interval. We're talking about distinct points, just the number negative 3 and just the number 3. That's why they use curly brackets, all right? Because we don't want all the numbers in between. We just want the number negative 3 and we just want the number 3. So that's what curly brackets do. Just talk about a discrete set. Okay, let's look at this piecewise. Let me see the time. We got a solid 10 minutes. Find the domain of the function. Okay, it probably would help if we looked at the graph. Let's see. When x is less than 0, we have a diagonal line. Okay, I kind of want to graph this. I'm trying to decide if I'm going to graph it by hand or use a graphing utility. Because even if we use a Texas instrument, you still have to be able to interpret certain results. But I think we should look at the graph. Now we could graph this by hand, right? If we choose x is less than 0, plot the points, right? Let's do this by hand. I think that's going to be the best thing. And we can couple it with like some graphing software. Some free graphing software are things like GeoGebra or Desmos.com. These are two different sites. But let me show. Let's do this by hand. This might be the last one for the day. This comes from section 1.4, question 47. Right. So the first part, we have this 4 plus 2x, but that applies if x is strictly less than 0. The second one we have is x squared if x is greater than or equal to 0. This is our piecewise function. This is going to be f of x, okay? I'm just graphing this first. So let's hop over to the tablet. All right. So when x is less than 0, we have this diagonal line. When x is greater than 0, greater than or equal to 0, we have this parabola, right? All right. So let's do this. We have the origin here. Let's go, we can go like this. 1, 2, 3. I don't need that many. Then I'm going to copy and paste. I'm just making an XY plane. Copy, paste. Okay. So this is our origin. This is the positive x going in this direction. It's positive x, positive y is here. That's 1, 2, 3, 4. 1, 2, 3, 4. These are our negatives. These are our negatives. Okay. So let's do the first one. Let's do this first line in blue. I'm just, let's do this one in blue. That's fine. Okay, so what we're going to do is graph it like normal, but just be aware that this only applies when x is less than 0. So for instance, because there's no equal to, there's no bar, it should be open. Like for instance, when x is 0, y is 4. When x is 0, y is 4, but that's going to be an open circle because it's not defined when x is 0. Now I'm just going to choose x values that are less than 0, right? So to kind of save us some time. When x is -1, -1 times 2 is -2, plus 4 is 2. So then we get this point. When x is -2, we get 0. When x is -3, is -6 plus 4, which is -2. It's right here. And you should be able to see the pattern from here. So then -4 is -8, so that's -4, right here. This one, right? So then we get an image like the following. Let's do like this. Okay. Then let me do this really quickly. Style, I want to fill it with this, and come on. Okay. Okay. So that's, and let's thicken this up too. Style. Okay. So that's the first line, right? Let's do the second one. I guess we can do orange. Or actually, let's just copy, paste. But we want to do this one in orange. Okay. So now, this only applies if x is greater than or equal to 0. So when we plug 0 into that one, 0 squared is 0. So I'm going to copy this symbol that I already have. Not symbol, but I'm just going to copy this thing. Copy, paste, style. I want it to be a filled-in orange. Right? So when x is 0, y is 0, right? And then, for instance, when x is 1, 1 squared is 1, so we're here. When x is 2, 2 squared is 4, and then I think it just goes off the charts from there. Let's go like this. Can't hit my marks today. That's good enough. That's the gist of it. No, I'm not feeling that either. Okay, I can do something like this. And then what I'm gonna do, I'm just being a little meticulous. Actually, before I do my augmentation, that I essentially want this to be like there. This, nope. That's better. That's almost there. I'm just trying to get something digital that works properly. Let's go like this. So it feels like if I get this here, when I do 3, 9, that goes kind of far. I'm gonna go about there. Nope. No, go away. I'm gonna keep trying. Almost. Let's go a little higher. Let's go like here. Let's go like here. Can this do it? Let me see if I do it like this. Will this behave the right way? No. Okay, that kind of does it. I never thought to do it that way, but I get the desired effect I was going for. That was fun. Okay, that works. Something like that. Boom. Okay, that's much better. Let me do like this real quick. Oh no, what did I hit? Undo. Like this. Nope. Oh, I guess that does work actually. And then just to be consistent, something like this. It's better. Okay. Let's see something. There we go. Okay, sorry. Just playing around. Okay, we finally got it to fit. And anyway, so we get a graph like this, right? So essentially what you can do is like graph it like normal and then erase the part that you don't need. But yeah, this works, right? So this is the graph that we get. Let me see the time. I kind of want to show GeoGebra, but I'm just going to go with this for now. All right, so we get a graph like this. So now let's use this graph. Now, again, we can use GeoGebra and some other utilities. So let's go back and answer the questions. Let's try to write this one up. Find the domain, right? So with this image, again, if we were to take this and flatten it onto the x-axis, I think every x is going to be accounted for, right? There are no gaps or holes or breaks or anything like that. That doesn't get filled in. Okay. So this one, we would say all rows. Every x is accounted for. Okay. The x-intercept, so I'm just looking at my graph. It crosses the x-axis at -2 and at the origin. So I'm just going to put -2 and 0. Okay. Y-intercept, it touches the y-axis at the origin. The other one gets close to the y-axis, but it doesn't actually touch. And I think it's B is the graph that we got. Right. B. Okay, so that was fun. Was that it? Oh, the range, okay. So from this graph, the range is the very bottom to the very top. If we were to take this image and smush it onto the y-axis, I think every y is going to be accounted for as well. You might be tempted to say there's a gap, but it gets filled in. Like if we smush this image onto the y-axis, every y is accounted for. So we would say all rows. There are no gaps or holes or breaks or anything like that. Okay. So if there aren't any burning questions, we're actually going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care, guys. I'll see you next time.